So most of your concepts are pretty much the same as what you studied in O levels, but things can slightly get difficult, especially when it comes to balancing equations. Uh, so let's talk about redox reactions. Then we're going to come back to the moles worksheet. Redox reactions, you have reduction. And also remember, redox and electrochemistry is a topic that's going to be studied in detail in A2, in A levels in the second year. It's not a topic that's in detail in your AS. So reduction, whenever somebody is going to ask you about reduction, it's basically a gain of electrons. I mean, that's the correct definition of what reduction is. Uh, there are other things written about reduction, and oxidation is also, whenever somebody is going to talk about oxidation, that's specifically a loss of electrons. Just one second, let me add people. So you have a gain of electrons and you have a loss of electrons. But there are other ways of describing that which are not technically sound, but they work as well. So reduction is gain of hydrogen atoms. Not the neutral atoms, not the H plus one ions, or it's the loss of oxygen atoms, or reduction is reduction in oxidation state. And we're going to talk about what oxidation state is. Oxidation state is simply right now just think of it as the charge, but there's a difference, and I'm going to explain what's the difference between oxidation state and what's the difference between charge. So on the other hand, oxidation is the opposite. It's the gain of oxygen atoms, and again atoms. It's the loss of hydrogen atoms, and it's the increase in oxidation state. So whenever you see charge increasing or decreasing, you can spot whether reduction or oxidation is happening. Whenever electrons are gained and whenever electrons are lost, the charge decreases when electrons are gained and the charge increases when electrons are lost. So this is easy. Can anyone tell me what this is? Like aluminium goes from neutral to Al plus 3. So what's happening to the charge? Is it losing electrons or is it gaining electrons?
Losing electrons.
Okay, so it is losing electrons because there's an increase in oxidation state. There's an increase in charge. It goes from 0 to plus 3. And it lost exactly how many electrons? It lost exactly 3 electrons, and that's oxidation. And whenever you see charge decreasing, so for example, oxygen goes from 0 to minus 2. So that clearly means the charge is decreasing. That's a reduction. That's a gain of electrons. That's a gain of 2 electrons. So that is clearly reduction. Now, this is something that's very obvious, but people kind of still get confused with this. So just remember, just think of it, charge dropping, that's reduction, charge increasing, that's oxidation. So I'm just going to give you, can anyone tell me what's happening here? Like if there's Na plus 6 and it turned into Na plus 7. So what took place? Oxidation or reduction?
Oxidation.
Okay, so that means it lost 1 electron, right? Charge increasing is oxidation. So on the other hand, you've got, let's say you have Cl plus uh, plus 2 going to Cl minus 8. What's happening here?
Reduction.
Okay. And how many electrons have been gained? How many electrons have been gained?
10.
Okay, you gained 10 electrons. You went from plus 2 and you went all the way to minus 2. So that is reduction. Okay, so keep this in mind. Charge reducing, decreasing, that's reduction. Charge increasing, that's oxidation. Okay, so that's one very basic thing. Don't get that wrong. Now the other thing is, what is oxidation state? So that's another thing. Okay, what is oxidation state? Now, what oxidation state? Now, oxidation state is kind of slightly, very slightly different from what charge is. Oxidation state is, it's the charge on the element if the substance was ionic. So there's a big if the substance was ionic. Not all substances are actually ionic. Like for example, NaCl is ionic. So that clearly means Na is plus one and Cl is minus one. But a lot of substances are not actually ionic. And one example for that is you have an HCl molecule. Now, HCl is a covalent molecule. That means, like in the NaCl, Na actually loses one electron and Cl actually gains one electron. So that is reduction and oxidation happening. Na is getting oxidized and Cl is getting reduced. But in HCl, there is actually, it's a covalent molecule. No one is gaining or losing electrons. But we still say that H is plus one and Cl is minus one. So why do we say that? Even though Cl is not gaining the electron and H is not actually losing the electron, they actually look like this. That you have Cl with its 7 electrons, and you have H with its 1 electron. So the H ends up sharing electrons with Cl. So no one ended up gaining or losing electrons. So why are you giving them charge? So I'm going to explain that. So just remember, for covalent molecules, you're going to give them charge and you're going to think of them as if they're ionic. So why did I give them charge? So let's talk about that. The reason we gave them charges is that in the periodic table, there's a concept called electronegativity, which is that if you move to the right of the periodic table and if you move to the top of the periodic table, this concept, electronegativity, it increases. So elements, they kind of become more electronegative. So electronegativity is the tendency for an atom to attract electrons. So if I call something electronegative, that means it has a very strong tendency to actually attract electrons or gain electrons. Like Cl is very electronegative, which means that Cl likes to attract electrons. And I'll just briefly, I'm not going to go into a lot of detail about electronegativity, but I'll just give you an idea of why. I'm just going to open the AQA period table just to show you. So this is the periodic table, and so this one. You move to the right, the tendency for an atom to gain electrons, it kind of increases. Like fluorine is one of the most electronegative elements, whereas lithium, on the other hand, is it's not a very electronegative element. So why is that? Why is the electronegativity increasing when you move to the right? It's increasing because who attracts electrons? It's the protons in the nucleus that attract electrons. So lithium over here has a charge of three. I mean, it has 3 protons in its nucleus. But in the same row, there's another atom, fluorine, which has 9 protons. So who's going to attract electrons very strongly? It's going to be fluorine. So when you move to the right of the periodic table, uh, what happens is that the elements, they have more and more protons. So pick any row. Sodium over here has 11 protons, chlorine has 17 protons. So if it has 17 protons in its nucleus, it's going to be holding on to its electrons very, very strongly, and it would be attracting electrons very, very strongly. Okay, is this point clear? One second.
Yes.
Just ठीक है है ना. Actually there, Mariam, are you, नहीं ठीक है, चल ठीक है. अच्छा, so when you move to the right, the nucleuses, they have more protons, so obviously they tend to attract electrons more. I mean, I can show you a fluorine atom. Okay, so this is how the fluorine atom looks like. It has a lot of protons in its nucleus, right? So if it has so many protons, 9 protons, so it's going to attract its electrons kind of strongly. Lithium, on the other hand, has very few protons in its nucleus, so it's not going to attract its electrons very strongly. So that's one thing. Electronegativity increases. The tendency for the atom to attract electrons increases. On the other hand, if you go down the group, the electronegativity kind of drops. And the reason that happens is that if I show you what happens down the group, the atom size becomes bigger. So let's see if we can have an image of an iodine atom. Okay, so look at an iodine atom. Uh, the iodine atom has so many electrons that the nucleus is kind of hidden by all those electrons. So if there's another electron that's roaming around, that electron would not really be attracted to the iodine atom because it already has so many electrons. These electrons would be repelling that extra electron that's coming from the outside. So when you move down the group, the number of electrons and the size of the atom, it kind of becomes bigger and bigger, and which is why it becomes harder for the atom to actually attract electrons. So two things: electronegativity increases to the right, and it if you move down the group, you get bigger atoms, and the electronegativity kind of starts to decrease. So right now, you just have to. We're going to talk about this in a lot more detail when we do chemical bonding. But is the basic idea clear? What electronegativity is? Is this clear? Yes or no?
Yes.
Okay.
Yes.
Okay. So and you also know that these are the ones that form negative ions. I mean, they always form negative ions, the ones that are on the extreme, right? Apart from noble gases, because noble gases, they don't have space for electrons, so they can't really technically gain electrons because they already fall. Uh, so fluorine over here is probably one of the most electronegative elements. So now the thing that I'm trying to tell you is that when you see a covalent molecule, so it's not perfect sharing that's happening. When you see a covalent molecule, for example, you see HCl. So there's H and there's Cl, and they have a covalent bond in between, and they're sharing 2 electrons. So the thing is that these 2 electrons are not exactly in the middle. Uh, Cl is somewhere over here on the right side. Cl is kind of very electronegative. I mean, you already know that Cl likes to gain electrons, right? So these 2 electrons would be kind of really close to Cl. I mean, they would be kind of really close to Cl. I mean, Cl is very electronegative, so Cl would be, the molecule would still be covalent. I mean, Cl would not be able to gain all of the electrons uh, because the H is also a non-metal, and non-metals always they tend to pull electrons. And I'm also going to tell you that there's a thing called a Pauling scale, which Pauling scale. Just one second. Okay, it's not part of your course, but it just gives you an idea of, for example, this is the Pauling scale. It gives you an idea of. I mean, electronegativity is part of your. Just a second. Open image in new tab. Just a second. So here's your Pauling scale. These are values that are calculated in a certain way, and the Pauling scale gives you which element is the most electronegative. So you can see over here 3.98. So fluorine is kind of really, really electronegative. Uh, so why do covalent molecules share electrons? Because the reason covalent molecules they share, sorry, not this one, this one. The reason covalent molecules share electrons is because both atoms are trying to pull electrons. I mean, chlorine is trying to pull electrons to one side, right? So chlorine is trying to pull the electron with a slightly stronger force. And at the same time, hydrogen is also trying to pull electrons, but the force of attraction for hydrogen is slightly weaker. It's like a tug of war happening between two atoms. Uh, and you can see over here in the Pauling scale, fluorine is 3.98 and H is 2.2. So I mean we're talking about chlorine actually. Chlorine is 3.16 and H is 2.2. So the force of attraction of chlorine for electrons is kind of slightly stronger. So because of that, what happens is that the electrons are kind of closer to Cl. So it's like a tug of war that's happening, and the electrons are kind of closer to they're kind of closer to Cl, which is why the electrons are not perfectly they're not perfectly shared, and that happens pretty much in all covalent molecules. The electrons are never actually always in the middle. They're not actually always shared. They're somewhere in the middle, but they're closer to one of the atoms. So what you're going to do is you're going to treat this molecule as if it's ionic, because when we are talking about oxidation reduction, I don't really care whether the atom is able to gain the electrons completely or just partially. I just want to know, out of the two, who's the one who's winning. It's like a tug of war that's happening, and this is the middle. I just want to know who's winning. So, like, who's trying to pull the electrons, who has a stronger force of attraction for electrons. So, when it comes to reduction and oxidation, I don't really care whether they're able to completely gain those electrons or not. That's not my headache. I just want to know who's winning. So, over here, Cl is more electronegative. So, Cl is the one that's actually so I'm going to treat it as if it's ionic. I'm going to treat it as if it's ionic. I'm going to give those electrons to Cl. I'm going to say that Cl is one. Cl is the one that's gaining those electrons, even though it's only partially just pulling those electrons closer to it. And I'm going to say that H has lost those electrons and H is plus one. So that's not the actual charge. What that simply means is that Cl, out of the two atoms, the electrons are closer to Cl. So that means Cl is the one that's kind of gaining those electrons, and H is the one that's kind of losing those electrons. So is this idea clear to everyone? France, is this clear? Kauser, Mariam?
Yes.
Yes,
So,
sir.
okay. So so just remember that ionic compounds, the electrons in ionic compound, the tug of war is kind of one-sided. In ionic compound, what happens is Na and Cl, they both had one electron each. But if you look at the Pauling scale, like if I open the Pauling scale, there's a huge difference. Na is like not even electronegative; it's 0.93. Cl is 3.16. So that's like a one-sided competition. It's like a one-sided competition where Cl would be able to just gain those electrons completely. It's not even a match that's happening. It's so Cl would be able to gain those electrons completely. It wins. It wins it, and Cl gets a charge of -1, and Na gets a charge of +1. So in that case, they are actual charges. These are actual. This is a full blown +1 charge. This is a -1 charge. But in HCl, the competition is still going on. No one is a clear winner, but Cl is kind of the electrons are kind of slightly closer to Cl. So so that's the difference between what a charge is and what an oxidation state is. So in an oxidation state, you think of the charge on the element as if the substance was ionic, as if this molecule had actually, the competition was over and Cl had actually gained those electrons. So in oxidation state, you talk about it in absolute terms. You're going to just give this electron to Cl, that's it. So based on this, you calculate oxidation state. You always calculate, you look at a molecule and you figure out who's gaining electrons and who's the one who's losing electrons. So for example, you have, I'm going to try and do another molecule. Uh, so I've got oxygen with fluorine, right? So it's a covalent molecule. So overall, it has no charge, but obviously the electrons are not shared equally. Who's more electronegative, oxygen or fluorine? So for that, we can open the periodic table. Fluorine is right in the corner. So fluorine is 3.98. I don't know if you can see this. Oxygen is 3.44. Uh, So obviously fluorine is more electronegative. So that means whatever tug of war that's happening over here, the electrons would be slightly closer to. They would be slightly closer to these fluorine atoms. So that kind of means that fluorine would have one electron, so that's -1, and this fluorine would also be -1. I mean, one of the electron is its own electron, so I'm not so that doesn't count. It's gaining one extra electron from oxygen, so that's -1. And oxygen over here in the middle would be losing one electron to this fluorine, one of the electrons, sorry, and one of the electrons to this other fluorine. So oxygen over here is having a charge of +2. So is this clear? I mean, the idea is clear.
Yes.
ठीक है. Rest, Mariam, is this clear? Anna, is this clear?
Yes, sir.
Achha, so that's just the concept of what electronegativity is and how do you figure out the oxidation state. So whenever you're confused, uh, I mean, you're obviously not going to be given the Pauling scale. I mean, these values would not be with you. But the trend is you move to the right, the element becomes more electronegative. You move downwards, the electronegativity kind of decreases. Uh, so the corner part, this one is these are the most electronegative, and the other opposite corner, these are the least electronegative. These are the ones that are always losing electrons. So we're going to talk about oxidation states now. So obviously you can't always. So whenever you're confused, look at the negativity of elements. But otherwise, there are simple rules that you studied in O levels, which were for oxidation states, and the rules were that if you have a free neutral element, the oxidation state is equal to 0. It doesn't have a charge, so that means it neither lost or it never gained an electron, so it's 0. So for example, if you have a Cl2 molecule, that is 0. Why? Because that is perfect sharing. Because I mean, that's like a tug of war that's happening between two people who are having equal strength. Like both of them are Cl atoms. So where would the electrons end up? The electrons are not going to go anywhere. They're going to be stuck right in the middle. So no one would be gaining electrons and no one would be losing electrons. So that means the oxidation state is going to be 0. No one gets a charge. So when you have a neutral element like a Cl2 molecule or any atom, whether it's neutral, that has 0. The oxidation state is 0. Don't write charge. Okay. And another very minor thing about oxidation state is that the sign is written before the charge. Like if you call it +2, you call it -3, you call it +1. Okay. So the sign is written before the value. When you talk about charge, the sign is always written after the value. Like Na has a charge of 1 plus, not +1. +1 is the oxidation state, 1 plus is the charge, but it doesn't really matter. No one is going to, you're not going to lose marks for that, whether you write +2 or 2 plus. But if you were getting a distinction, you might lose your distinction for that. Like for distinctions, they actually look for these minor details, that how good was the paper attempted and how technically sound was the paper. Like you got 5 people in the world who have 100 out of 100, but who attempted a better paper. So in that case, this thing would be considered. So anyway, so you have now let's talk about compounds. So when you have compounds, someone would be gaining electrons, someone would be losing electrons, like NaCl or like HCl or like all the molecules that we did. Uh, so compounds, they're two different substances. So they're never going to have the same electronegativity. So one of them would always be trying to gain the electron compared to the other one. So when it comes to compounds, first thing is group 1 is always +1. Group 2 metals would always be +2. Group 3 metals would be +3. And then you've got transition metals. They have variable charges, so they can take on any charge they like. So you would have to calculate them. So they're going to have variable charges. So you can't really guess what the charge is unless you do some calculation. Then you have oxygen, and and it's usually -2, but there are a number of exceptions. For example, except the one that we did over here, like oxygen with fluorine. In that case, oxygen is not -2; it's actually +2. So so that's one exception. You've got peroxides like hydrogen peroxide. So just remember these a couple of exceptions. So you've got
Sir,
yes.
could you please explain the difference between oxidation and reduction again?
The difference. I mean, it's gain of electrons, loss of electrons. I mean, this one.
Yes, sir.
We haven't actually we were talking about oxidation state at the moment, but reduction is when a substance gains electrons, and oxidation is when a substance loses electrons, right? So, for example, aluminium over here is going to +3, so that it's losing 3 electrons. When something gains electrons, its charge decreases; it becomes negative. When something loses electrons, its charge increases. So, oxidation would be if the charge increases, reduction would be if the charge decreases. Okay, that means it's gaining electrons, otherwise it's losing electrons. But we're gonna come to reduction and oxidation a little bit later. Okay, we're gonna come to that later. We're gonna try and find out what reduction and oxidation is. Uh, right now, we're trying to figure out in a compound who's the one who's gaining electron and who's the one who's losing electrons. Like if you want to talk about this one, fluorine is the one that's gaining electrons. So it's, I mean, you can say that fluorine is the one that's getting reduced. Oxygen is the one that's losing those electrons. So oxygen is the one that's kind of getting oxidized. France, is this clear?
Yes, sir.
Okay, so I mean, this is one way of figuring out oxidation states. The thing that we're trying to figure out is a smarter way of actually figuring out oxidation state, and that is that we know the oxidation state of some of the elements in compounds. Group 1 is always +1, group 2 is always +2, group 3 is always, I mean, these are always, they have fixed oxidation states. Uh, Oxygen is always -2 because oxygen is always trying to gain electrons. Why? Because oxygen is also one of the most electronegative elements. So if you combine oxygen with any element, it's always trying to pull those electrons towards itself. It has a very high Pauling scale value. It has very high electronegativity. Uh, the only element that's more electronegative than oxygen, that's fluorine. Then you have hydrogen. We know the oxidation state of hydrogen. That's +1. Most of the time, it also has exceptions, except in metal hydrates when it's bonded to metals. Like in NaH, H would be -1 and Na would be +1. I mean, you can have a look at the Pauling scale. H is 2.2, Na is 0.93. So H is more electronegative than Na. So H would pull the electrons from Na, and H would be the one that would be gaining electrons. But H with any of the non-metals, H would be the one that would be losing electrons. Like with oxygen, with nitrogen, they are more electronegative than H. So H would be losing electrons, and H would always be at the losing end. It would always be losing electrons. And lastly, there's fluorine, which is the most electronegative element. So fluorine is always -1. Okay, you attach fluorine to any element, fluorine is the most electronegative. So it's going to try and pull those electrons, whether completely, it might gain those electrons completely, or it might gain those electrons partially. So fluorine would always be the one that would be gaining electrons. So is this clear? This thing, you did this in O levels as well. So is this clear to everyone?
Yes. Yes.
ठीक है. I said the only thing is, if you get confused with this, like if you get an example where you can't use these things to find oxidation state, then look for the electronegativity thing. Okay, you can pretty much figure out of the two elements which one would be the more electronegative, so the electrons would be closer to it, and that one would be the one that would be gaining electrons. Anyways, so that's about it. This is a table that you should remember, and based on this table, you should be able to calculate oxidation states of different substances and elements. For example, there's a substance called NaClO3, which is sodium chlorate. So I want to figure out what the oxidation states of each of the elements is. For Na is group one, so I know for group one is always +1, so that's already known. Oxygen, the table says that oxygen is -2, so that's also kind of known. So oxygen is -2. Table has no information about chlorine, so I have no idea what chlorine is. So I'm going to say that chlorine is X. We don't know what chlorine is. So how do you find the oxidation state of unknown elements? What you're going to do is, I mean, this is a neutral compound, so that means all the individual charges must add up to be equal to 0. So you have +1, which is Na. Cl, that's not known, so that's X. And oxygen is -2, but there are 3 of them, so that's -2 into 3. You add up all the charges of the individual elements, and since the molecule is neutral, make them equal to 0. And once you solve this, what you're going to get is -6 goes to the other side, so that becomes +6, and then it's -1, so that's +5. So that tells you that Cl over here is actually +5, right? So that's how you're going to try and figure out the oxidation states of elements which are not given in this table over here. Let's try and do another one. Let's try and do carbon dioxide and try and figure out the oxidation state of carbon dioxide. Again, I don't know what carbon is, so that's unknown. But oxygen is given in this table over here. That's -2. So I can figure out X because carbon dioxide is a neutral molecule overall. So that means carbon's charge and there are 2 oxygens. So that's -2 times 2. The individual charges of the elements must add up to be equal to 0. And if I solve for this, the X comes out to be +4. So that means carbon over here, which I didn't know what it was, but now I know it's +4. Okay, so is this clear? Alicia, is this clear? Zebi, is this clear?
Yes.
So you can kind of figure out the oxidation states of unknown elements. We're going to just try and do a bit more questions. That's what we're going to do. Let's try and do H3PO4. And we're going to try and figure out the oxidation states of the elements. H is known, that's +1. P, I don't know what P is. That's X, that's unknown. Oxygen is -2. So add up the charges, and it's a neutral molecule, so that's +1 into 3. There are 3 hydrogens. Then add the uh, P is unknown, so that's X. And then it's -2 times 4. There are 4 oxygens. And they should all be adding up to be equal to 0 because it's a neutral molecule. So that would give you, if you solve for X, that would give you +5. And let's practice one more. Sometimes what would happen is that the molecule would be a polyatomic ion. It would have a charge. So for example, in this case, like if I take Cr2O72 minus, it actually has a charge. I mean, there's a -2 charge on the whole thing. So the molecule is charged. So there's chromium, which I'm not sure what the oxidation state is. I'm not sure what chromium is. So that's X. But I do know that oxygen is -2. So there are 2 chromium, so that's 2 times X. And there are 7 oxygens, so that's -2 times 7. And the individual charges must add up to be equal to, the individual oxidation state must add up to be equal to minus 2. And if I solve for this, 2x would come out to be equal to minus 14 goes over there. So that's 14. And x comes out to be equal to, not 14, that's 12. And x comes out to be equal to, it comes out to be equal to 6. Uh, so just remember how to find out oxidation states of different elements. So this is what we are going to do right now. Just try and let me just send you a worksheet on finding oxidation states. 1 second. So that's this one. So we're going to work with this sheet. So this is your assignment for now. So just try and find out the oxidation state of, assign oxidation states on all the elements that you see over here. See this one. I'm sending it in the group. Okay, also posting it on the, just a second.